So here we have another question. A block of mass m1 with this much, like 1.6 kg, initially moving to the right with the speed of 4 meter per second. So the initial speed of first block is 4 meter per second. On the frictionless horizontal track, collide with a spring attached to the second block with mass 2.1 kg, initially moving to the left with the speed of negative 2.5 meter per second. The spring constant is 600 Newton, and they want us to find at the instant block 1 is moving to the right with a speed of 3 meter per second. Determine the velocity of block 2. So here we have diagram. Block 1 is moving in this direction with this velocity. This is the initial velocity. Block 2 is moving in this direction. This is its initial velocity, and this spring is attached to the block 2, and this will collide with the spring, not the whole block. So after the collision, this is our case. This is our whole case after the collision, and this is the final velocity after the collision of block 1, and we have to find final velocity of block 2 after the collision. So we know, like, first let us write up all the data which we have. m1 is equal to 1.6 kg, v1i is equal to 4 meter per second, which is the initial velocity of block 1, m2 is equal to 2.1, v2i is equal to minus or negative 2.5 meter per second, which is initial velocity of block 2. Spring constant is 600 Newton. Final velocity of block 1 is 3 meter per second, and final velocity of block 2 we have to find that. We know momentum is equal to m times v. So here momentum of block 1 plus momentum of block 2 is equal to momentum of block 1 plus momentum of block 2. But the twist is, this is the momentum before the collision is equal to the momentum after the collision. So here, similarly, in our lot of cases which we have studied, the total momentum is conserved. Total momentum is conserved. So there is no loss in energy. So we can just simply say P1 plus P2 is equal to P1 plus P2 before and after. Before the collision and after the collision. So P is equal to M times V. So P1 is equal to M1 V1I plus M2 V2I is equal to M1 V1F, which is final, plus M2 V2F. So V1I is the initial velocity of block 1, V2I is initial velocity of block 2, V1F is the final velocity of block 1, V2F is the final velocity of block 2. So substituting all the values of the variable and doing some calculations or maths, we will get this equation. And by subtracting both the side 1.15, this will become 0, and this side 4.8 minus 1.15, and then doing further calculation we will get this value, and so dividing this we will get negative 1.74 meter per second. So the final velocity of block 2 will be negative 1.74 meter per second. So now for part B, we can say that initial kinetic energy is equal to final kinetic energy plus potential energy of spring. So we can see that initial kinetic energy is equal to final kinetic energy plus potential energy of spring, and potential energy is given by half kx square, which is this, and general formula for kinetic energy is half mv square. So let's substitute, or let's find first initial kinetic energy. So initial kinetic energy is m1 v1i whole square plus half m2 v2i whole square. So substituting all the values of these variables, we will get 19.36 joule. Similarly, let's find the kinetic energy of, like, final kinetic energy. So for that, half m1 v1 f square plus half m1 v2 f square. So this is final velocity after the collision. This is final velocity after the collision. This is the velocity before the collision, initial velocity before the collision. So let's substitute all the value of this equation from our data, and doing further calculation we will get 10.38 joules. So now let's take our first equation, which is this: initial kinetic energy is equal to final plus potential energy of spring. So subtracting both sides by final kinetic energy, and we'll get this equation, or simply this came here and it will become negative, and this is as it is. So let's substitute the value of initial and final kinetic energy and subtract it. Will give you 8.98, and PE is equal to half kx square, which is the formula for potential energy of a spring. So we have the value of k, which is 600 Newton. So we have substituted that, and by doing some math we can find the value of x. So the value of x will be roughly 0.173 meter. So this is our part B. this is a party.